Welcome back to Transcended. So in this video, I'll just take you over some questions under differential calculus, and this is a very good foundation if you are somebody who is trying to look for a basic foundation to differentiation. Cover limits, we got to the continuity, discontinuity under limits. We're defining the functions to ensure they are continuous at given points. First principle, determining the tangent of a line at a given point, the chain rule, product rule, quotient rule, even applying them to trig functions. Then we have implicit differentiation, first and second derivatives of functions, mostly trig and logs, exponentials. So let's get into it. So the first one says the limit as x approaches 2 for x squared minus 8x plus 3. This is something very basic and straightforward. So the rule of the thumb is whenever you're dealing with limits, if it's a basic function or if you do substitute directly a given value and everything is okay, just do that. So what is the value of y as x becomes 2? So just substitute in this case. I don't think there's going to be anything that will make the function undefined. Let's do that. So we have the limit as x approaches 2. Then where there is x, we're going to put 2. So it will be 2 squared minus 8. Instead of 8x, it will be 8 multiplied by 2 plus 3 right there. So 2 squared, that's going to be a 4. So 4 minus 16 plus 3. So 4 minus 16 is negative 14. No, 4 minus 16. Yeah, 4 minus 16 is negative 12. Sorry. Negative 12 plus 3. That's going to be minus 9, right? So I believe that should be our answer there. Okay? If my math is okay. We'll move. The other one, simple and straightforward as well. Let me just give you an example of the one that becomes undefined. Look at the C. If we are to say x to the power 3 minus 8 and then x minus 2, we are saying the limit as x approaches 2. What's happening there is if we are to put where there is x there on the denominator, we put a 2. We're going to have 2 minus 2, which will be a 0. Now you and I know that you can't divide by a 0, which makes the whole expression undefined. So that's why we have to counter check that before we do anything. Taking back to B, the limit as x approaches negative 3, the root of 13 minus 4x. So the idea is think of a radical, think of a square root. What makes it undefined? What makes it undefined is when you get a negative under the square root. Now in this case, if you put in a negative 3, are you going to get a negative or not? So just substitute. The limit as x approaches negative 3, the square root there will be 13 minus 4. Our x is negative 3 right there. And then we're going to have the limit as x approaches negative 3 as what? So I'll just go direct to the answer. 13, negative 4 times 3 is 12. So that's going to be 13 plus 12. So that's going to be 13 plus 12 is what? 25. So that's going to be 25. So root of 25 is just going to give us a 5. That's how we under the first two. Quickly move to the third one. The limit as x approaches 2, x to the power 3 minus 8 over x minus 2. So I've already shown you to say if you are to substitute 2 directly into that expression, you and I know that you're going to get a 0, right? So 2 to the power 3 minus 8 over 2 minus 2. You're going to have 8 minus 8, 0, 0. That is an undefined expression. So this is where now you begin thinking when it comes to the limits. How can you express this in a way that you avoid getting a 0 on the denominator. So these are two things you can divide. If you can remember your polynomial functions that you did earlier on. If you're new to that, you can watch my video where I've explained how to divide polynomials, right? So x minus 2 can be divided into x to the power 3 minus 8. Okay. Now the basic idea that I've explained to you already when it comes to dividing polynomials, ensure that you introduce imaginary numbers or where the powers are not decreasing in the descending order properly. So we've got a constant 8. So we're going to introduce 0x squared, because normally from 3 you're supposed to go to the power 2, and then 0x, and then we can now have the minus 8 as a constant at the end. So you can use long division, you can use synthetic division to get the other the divisor. It doesn't matter. Okay, so I'll use long division for this case. I rarely do that. I'm shocked actually. So x divided into x to the power 3, this is x squared. Because I actually do videos without planning, so this is just freestyle. So x squared can be multiplied by what we have here, and so if you do multiply x squared times x, that's going to give us x to the power 3. X squared multiplied by this negative 2 is going to be minus 2x squared. At this point, just like the way we do the normal long division, we have to subtract. 0 minus this is going to give us a positive 2x squared, right? Again, at that point, we'll go on, get that x, divide into that. X into 2x squared is going to be plus 2x. Okay? So the plus 2x again can be multiplied with this expression. Plus 2x times x is going to be 2x squared. Plus 2x multiplied by negative 2 is going to be minus what? Minus 4x. Okay. So subtract again at that point. Remember we've got 0x there. Okay. Which we can drop right there. So this is just going to subtract. 0 minus negative 4x is going to give us positive 4x. And then the 4x can be divided by x again. So 4x divided by x will give us 4. 4 times 4x, or 4 times the x, will give us 4x. 4 times the negative 2 will give us minus 8. We can drop that minus 8. And if we do subtract these, you'll see that you actually get a 0, which implies that whatever you have on top there is a factor. So therefore, the limit as x approaches 2, the top part is divisible by that. So implying that the product of x minus 2 and this guy on top, if you do multiply them, we are going to get what we have on top. So on the bottom we have x minus 2. So some of you don't get what I've done here. So two factors. If you say, for example, 8, if you say 8 divided by 4, it gives you 2. The implication is 4 times 2 should be able to give you what? 8. So we divided that guy on top. Okay, the result we got was x squared plus 2x plus 4, implying that if you multiply this guy and that guy, they should give you that. And that's exactly what I've done. I've substituted that top part by the product of these two. Okay, now you can see that we can divide this and that part, right? So that we just remain with a limit as x approaches 2, and then the only expression that stands out is x plus 2x plus 4, which is a polynomial, and that makes things easier. It's a quadratic function, it's continuous, so you can just substitute the value of 2 and you get your answer. So you're going to have 2 squared plus 2 multiplied by 2 plus a 4 there. That is a 4, that is a 4, that is a 4. 12 is the answer. Okay, so I'm using the same idea there. I want you to pause the video and try out D. Similar question. You can expand the denominator in the similar manner. Okay, so of course if you do substitute the 3 directly, you're going to get 0 over 0, which is an undesirable state. Okay, so hopefully you've paused the video and you've attempted to answer it. So the limit as x approaches 3, x minus 3 divided by x to the power 3 minus 27, right? Can we now divide the smaller one, of course, which is x minus 3. In this case, I'll use synthetic division so that you're introduced to it as well. So get the factor of a divisor, x minus 3, and equate it to 0. It is going to give you x is equal to 3. So get that 3, draw a line, and yeah, get the coefficients of the bigger part. So x minus 3, in the similar manner, we're going to introduce imaginary parts. 0x squared plus 0x minus 27. At least we have the powers in the desirable order from 3, 2, 1, and finally x to the power 0, which is just a constant 27. Get the coefficients. So 1, 0, 0. So 1, 0, 0, minus 27. Okay? Those are the coefficients. The first step is to drop the 1. The second step is now to start multiplying with the 3. 3 times 1 is 3. You add the 0, 3, multiply, 9. You add the 0, 9. You multiply with the 3. That gives us 27. You add 0. The last part is the remainder. The first 3 are the coefficients. Remember, 1 was having x to the power 3. That was x squared. That was x. That was a constant. So the power reduces by 1. This will be x to the power 2. That will be x. And that will be a constant. So it becomes a quadratic, right? So therefore what we have is, after dividing, we are divided by what? We are divided using x minus 3. So we can expand. I want you to write an expression for that denominator. So we are divided by x minus 3, and our result was x squared plus 3x plus 9, right? Okay. So whether you use long division or synthetic division, it doesn't matter. So at this point, you can now see that x minus 3 can divide, and so that gives us a 1. So we have the limit as x approaches 3, 1 over x squared plus 3x plus 9. And you're now at liberty of just substituting your values, right? 3 there, 3 squared, that's going to be a 9. 3 times x, that's going to be a 9, plus 9, so that's going to be 27. So giving us 1 over 27. Yeah, that's it. That's it to D. We can now move to E. Now we are on E. The limit as x approaches 1, x minus 1 divided by 2 minus root of 5 minus x. Okay. Basic question. Are you able to answer it? So if we try to substitute directly our 1 minus 1 is 0 on the denominator. If we put a 1 where there's x, 5 minus 1 is going to give us a 4. It will be 2 minus root of 4. Root of 4 is 2. 2 minus 2 is 0 as well. So this is also undesirable. So what do we do? Okay, let's get into it. So this is something that we can deal with Okay, these are SADs. By looking at the radical that we have on the bottom, okay, we can multiply by what we call the conjugate to just like do away with that. So let's change the sign in between the denominator and we'll multiply it with both. So 2 plus 5 minus x. The idea of mathematics is don't change anything. So whatever you do to the denominator should be done to the numerator as well. Okay. Some of you have done multiplications of a SAD with its conjugate on many occasions, and you understand what happens is the middle part subtract. So it's a sheer waste of time for you to do a complex multiplication. Okay. So let's get into it. So the limit as x approaches 1. For the top part, we're going to remain with x minus 1 multiplied by 2 plus root of 5 minus x. For the denominator, I don't want to waste a lot of your time. If you want, you can try multiplying 2, multiply everything there, and then afterwards get the negative root of 5 minus x again and multiply everything there. Okay? But for the sake of what you need to do without wasting much of your time when you're multiplying by the conjugate, just get the like terms. 2 times 2 is 4. This times that, the sign will be a negative. Negative times positive is that negative multiply that positive will just be a negative. Then square root, so root of 5 minus x multiplied by root of 5 minus x. The square root basically just disappears, right? So we remain with 5 minus x. Because you and I know that a square root is the same as power half. So 2 multiplied by 2 to the power half multiplied by 2 to the power half, maintain the base at the powers, it will just be the power 1. So that's how the square root disappears, in case you never knew. And yeah, I can confidently say that what remains is the limit as x approaches 1, and yeah, we've got x minus 1, and then we have 2 root of 5 minus x divided by, we can do some simplifications on the denominator. So if we do distribute the negative, we are going to have 4 minus 5, and then that will be plus x. So 4 minus 5 is what? Negative 1. That will remain as positive x. So you can just swap them. 4 minus 5 is negative 1. So that will just be x minus 1. You can see now this can divide. And then you remain with that part. 2 plus root of 5 minus x. You can now confidently substitute, right? So the limit as x approaches 1, 2 plus root of 5 minus 1. 5 minus 1 is 4, root of 4 is 2. So you end up with 2 plus 2, which is a 4. That's how you handle question E. Okay? Now, I want you to pause the video and just try to attempt to answer F. I want you to attempt to try to answer F without checking my solutions. Okay? So what is your answer on F? I'm interested to know. So hopefully you have paused the video. Actually, the answer that you should get, I want you to give a comment. Give us a comment. Okay? And I'll confirm if your answer is right. I do check the comments, so feel free to always ask a question if you have a question as you're watching our videos. And the comments, in fact, the comments are actually instant. They instantly reach my phone and I check them. Okay, and then we'll go to G. If you've observed the last 3 functions or rational functions, they are fractions. and they appear to be in very simple terms, in a way that you can't do anything to change them because they're already in their most simplified form. No expansion, no factorization can be done to them. But again, if you observe them, again, they are giving you zeros if you do substitute directly. So how do you handle these? Okay. So we handle these ones by graphing. Just a quick sketch of a function is sufficient to help you determine the answer. Okay, so I wanted to just have a few things by your fingertips that are very key when it comes to the sketching of rational functions. So the simple rule is the vertical asymptote. If I was to give you the graph, the vertical asymptote, vertical, you know what vertical implies, right? Okay, up, down. So a vertical asymptote can just be determined by getting a point where the denominator is equal to 0. At what point is the denominator equal to 0? Because that is an undesirable state. So when the denominator is equal to 0, that is your vertical asymptote. So for the first one, for example, x plus 1 equated to 0, at what point is it going to be 0? It's at x is equal to negative 1. When you do substitute at negative 1 plus 1, that's going to give you a 0. So at that point, the function shouldn't cut it. So that becomes our vertical asymptote. For the horizontal asymptote, the rules are also very simple. Okay. So for the horizontal asymptote, if I start with this very example where the denominator is heavier compared to the numerator, implying that we've got a higher power on the denominator compared to the numerator, just know that y is equal to 0 is the horizontal asymptote. That implies the x-axis is the horizontal asymptote. Okay. In a case where the numerator is greater, for example, like x squared, okay, plus divided by x minus 1. In this case, the order of the numerator is greater than that of the denominator. In that case, you have what we call a slant asymptote. Okay. If you're looking for a video about that, I'll attach it in this video, just the link in the description below. You'll be able to check it out. Okay. So that you understand more about how to go about the sketching of rational functions. Then the one that I haven't mentioned is where the orders are the same. Let's say x minus 1 and x plus 1, for example. These are all to the power 1. So what you do in this case is easy. Get the coefficients of the highest powers, right? In this case, you'd get 2 over 3. That would be your horizontal asymptote. Okay. So now I've given you basics that are sufficient for you to sketch. Now in this case, the denominator is, for all the three, the denominator is like greater. So y is equal to 0 remains our horizontal asymptote. Okay, the x-axis. Then for the first one, equate the denominator to 0. It's x is equal to negative 1. That's your vertical asymptote. So how do you expect when it comes to sketching of this function? Okay, so it's just going to be something like this. Okay, and then to be reflected again on this side. Okay, remember we are trying to sketch based on the asymptotes. This is the vertical asymptote, this is the horizontal asymptote. And again, if you actually attempt to substitute, let's say a value less than negative 1, let's say 1 over, let's get a negative 2. Negative 2 plus 1, that's going to be 1 over, negative 2 plus 1 is going to be a minus 1. That's going to give us negative 1. Okay, in this case, it becomes a different case. It becomes a different case, implying that I'm wrong in my sketch. So it means it's going to be like this. Then the other side it will be like that. Yeah, that's the implication. Okay, so actually if you try a value, maybe a 0, if you try a 0, you will notice that it's actually cutting at 1 there. And if you try a 0.5, 1 plus 0.5 plus 1, you see that 1 over, and then you try negative 0.5 plus 1, you get a positive half being divided into 1, which will be 2. So this is actually the way it's coming out. Yeah, so you see that I also make mistakes, right? So the limit as x approaches negative 1, if we're to go from the left side, as we are approaching negative 1, what is happening? We're going down and down and down, implying that the limit as x approaches negative 1 from the negative side, for that function is actually giving us what? It's approaching, or it's heading towards negative infinity. Then if you try to test again from the positive side, from this side, as we are getting closer and closer to negative 1, which is our vertical asymptote, we are going up and up, which is the infinity. Okay, so that is positive infinity. Now the fact that these two are not the same implies that the limit does not exist, because the definition of a limit is whether you're coming from the left of the negative and the positive, they should be the same for it to exist. So in this case, because the two are not the same, it does not exist. Okay, so I want you now to attempt to sketch the remaining two and give me a comment if they exist or not for the last two. Okay, so the best way to handle math is just practice, 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 practice. So don't feel lazy to try them out. And yeah, let me proceed to answer question 2. Okay, so let me proceed to answer question 2. Follow through, and yeah, for those ones who want to access the full solutions to the tutorial sheet, you can just use the link in the description below. You can learn calculus from scratch on our site. In fact, all the topics are there in math and all the other courses, biology, chemistry, physics as well. Hi, so let me show you the questions that we've answered in this video. This is question 1, as you can see. Question 2, question 3, question 4. These are very interesting questions under differential calculus. Okay, chain rule, product rule, quotient rule, implicit differentiation, first and second derivatives of each functions. Then yeah, these ones as well. There is a part of determining whether a function is continuous or not. Then redefining the function to make it continuous at certain points is question 3. Then also first principle is question 4. So all these questions have been answered in details, and the link is in the description below to the solutions.